Okay, so this is the extra recording for 10:9. We're not going to do a lot here. I don't want you to get overly excited. I don't wish to do a ton. Um, but we do need to do a few things. I ended a lot earlier than I expected, so whatever. But I do need to go a little longer than that. Um, so I have some quick examples we're going to look at. The first one is my stat. Um, do, 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 do. Huh. It's kind of interesting. Let's actually run this. It says it's not going to run. Of course, it does run. It does not have errors. There is no home student code, me.txt. So none of this works. And you're like, wait a second. What do you mean? Device ID, none. It actually did the stat, produced an empty result. In no way did it actually determine that this wasn't actually a file name. So let's go and go to the terminal, present working directory, and let's change this to home student code and go 109, and then we're going to go 1. Okay, this is an executable. It's an actual file. Yay! Device ID is 2049. inode is 787.601. The size of the file is 16048. Now, if I type LSL, there are only two files here. 16048 is 1, and 949 is 1C. Okay. These do actually exist, so I'm really confused as to why it thinks they were not there. I think there's a library change or library difference here between the code completion and the actual compiler. Anyway, whatever. But we look at the output and we can see that 16048, the size of the file in bytes. If we look in the terminal, 16048, great. I want to look at output. We look at the size of the file via blocks. The block size is 4096. If we multiply those together, we end up with 131,072. So one should never assume that a file contains mostly is across an even sector, right? Like as an example, like it's across one block and then it's a full, fills up one block, fills up the next block and so forth. They're nice and contiguous. That is actually somewhat rare. As you can see, there are 32 blocks being used by 16,048 bytes. As you can see, you pretty quickly can multiply that times 4. That should really only use 4 or 5 blocks. But because we're trying to speed up the operations, we may move things around blocks. So it has to read all 32 blocks in order to read the file. Yay! So what time is the last access? Well, if you just print it out, which is what we're doing here, you get 172, whatever. You get this huge number, and you're like, why do I get that? That's actually the number of seconds since the epoch, or number of milliseconds, I think, since the epoch, or nanoseconds. I don't remember. Given the size, yeah, it's milliseconds. And you're like, wait a second, what do you mean? Okay. That's just what that means. That's how some computers keep time. Pretty simple. So we're going to play with time later. We're going to go back into this and we're talking about the nanoseconds, milliseconds, and so forth. Um, we don't really care. Let me see if it has. How do you say you do not have that? Of course you have that, right? There it is, right? I literally just typed it out. Um, yes, time, C time, whatever. Okay, nobody cares. All right. A couple of points, but we can't actually read that, so we use the ctime function. We're going to play with this later, but it takes the time and prints a character representation of it in the Unix fashion. If you type I believe it's time. Nope. Um, no. Nope. There's a command to get the current time, and I'm brain farting on it. Sorry, my dog is trying to get in. Come on in, Beignet. The dog's name is Beignet. Anyway, and I'm brain farting on it, but this is a pretty standard Unix way of keeping the time. When we do this later, when we play with the time functions, we're going to actually see C time a lot. C time takes um, a time t, and we can get that from mtime.tv seconds. It's a number of seconds. Yes. Great. And it takes those number of seconds and converts it to what looks like a standard Unix time. And you go, what do you mean? Well, if you look at the output, Thursday, October 3rd, it's a timestamp. Essentially, it's a timestamp. So Thursday, October 3rd, 10:15, right? 10:24. If you look at the terminal, it's a pretty standard way of doing time. Okay. This is an abbreviated version. There is a way of literally doing it. I just don't remember. Yep, nope. That's time up, by the way. That's uptime, kind of thing. But what I was going to say is there is a command to get the actual current time and what you call it. This is the most recent time, and you can see that's today, October 3rd, 15:29, which is to it's weirdly it should or says 15:19, but it is totally 3 o'clock right now. So I'm wondering if I redo it. No, it's definitely Eastern Standard Time. Whatever. As you can see, it's 15 instead of 3:25. It should be 3:25, which is, as you can see, it is a little behind. I don't care about changing the time zone. The last access um, is here. If I run the program again, right, every time I compile it, I'm getting a new, what's called the last XX time, as you can see, is in fact the same time. But if I do it again, it's, wait a second, the last access, if I gotta wait a minute, of course, I don't want to wait that long. Whew. Okay, so it's not going to access the whole file. It's just going to access the um, what's called, but you can see the modification date and the status change. You can absolutely do things like um, right. And if I run that program again, the last status change is actually should be updated to now. And you see that 1526. The last access, it had to access it in order to do the program, right? No, it's accessing it in order to run. Remember, we're actually running one. We're not doing anything with it. So if I change this to, yes, you can see that the last time it's modified and so forth, I can go and chmod it and I can actually get, you don't want to do that, of course, but if I run it now, you can see the access change time is actually different from the access and mod. When you execute a program, you are actually accessing it. So that's just what it is. I'm going to go back and change mode back again to 644 as the default 1.c, and that's just going to arrange it properly. Um, Yay. And that's pretty simple. There's only thing I think I left off of this, and we don't really care that much, is if you look at See, device ID, nobody cares. The inode number, yes. We didn't do anything with the inode number. I just want to show you the inode number. If I do ls dash I can't figure out why I can't type I. You can see the inode number actually matches exactly with what it showed here. 788 322, 788 322, right? By the way, I just shows the inode number. L gives you a long listing. Basically what that does. I like to do the long listing just so you can see it because it has the permissions and all the sizes and so forth as well. One other thing that we care about here is it has the number of links. I don't print that out here because we don't care, but that is actually important. We can actually print out the mode, but actually printing out the mode is actually not very useful on its own. Most of what we do with the node is instead of doing that, sorry, I don't know why. I'm just trying to write new file and go to.c is what we do with this is we do all this other stuff. And then we take the node, have it here somewhere. And then we do this little bit here, right? Where we switch on the mode. Oops, my stat dot mode. We and it. That's what this is with SIFMT. Why is it not let me type that? IFMT. What that does is it gives us um, a format. So I can go if, nope, I have it written wrong, SIF directory. And in here, I'm going to go printf. It's a directory, right? And I'm going to break here. We want to make sure we break here. And then I'm going to go case S ifreg. And ifreg is a regular file. Okay, this is not the best way to go. We're dealing with a direct, and as a result of dealing with the direct, we frequently do other things. And so, ta-da! This is 2. Oops. Oh, I just wrote prints instead of printf. And then we can go ahead and oops, I want to clear it out, and then we're going to go ahead and print. Run it, and you can see it's a regular file. Now, what if I make it 109? Okay, 109 here is in fact a file, right? It's not a regular file, it's actually a directory. So that works. Now, there's a large number of things you can actually do with those things, right? You can check the link, you can do those type of things, and so forth. We don't usually get the permissions here. We don't need to, because again, we don't really want to deal with permissions right now or ownership, but I'm going to play with ownership a little bit. I want to show you what that looks like just so we can see it. We're going to go ahead with a new text file. That's what I really should have done earlier. And we're going to keep this, but what I'm going to do is put a printf here. I'm going to go file type, right? Just so it gives me a nicer formatting here. Not necessary, just something I'm going to do. Okay. So we're going to printf user. Okay. Now, it is going to be by default a it does not like my stat for some reason. Oh, it's not really a file yet, so it's not doing completion. Okay, it's not doing code completions because it's not yet a C file. So we're going to use not the inode. I'm sorry, it's not the GID, it's the UID. There you go. And just so you can see what it looks like. I'm going to do the GID as well. It's not going to look very pretty initially, but right? Just give you kind of an idea or feel for it. It's not what you think it is. Another thing too we want to avoid dealing with directly is the device ID. It's useful to tell whether or not you're on one file system or another, but it's really not useful otherwise. We really don't do anything with it. Right, I'm going to stop that, run it. And you see user ID and group ID. Now, if I go back to terminal and I go, who am I? Right, I'm a student. Okay, that's not useful, right? 1000 is not what's called. Now, you don't need to know this, but if I cat password and I grep is a way of identifying a line in here that I'm interested in. I'm looking for student. You can see that the UID is actually 1000. When we go over processes and what you call it, we'll actually come up with a mechanism to actually go get it, right? To literally, quite literally go get it. And it's a very, very simple mechanism to use, and we're going to do it. Okay. Um, but right now we don't really care. Okay. But we can determine who owns something using MyStat. What else do we care about in MyStat? Blocks, we talked about that. That's important to know. Number of links, I really don't care. Size, nope. Don't care about any of those things. We are done with stat. Yay! All right. Now, we talked about changing permissions, but we really aren't going to do anything with that until we get to I'm sorry, let me think of the word. Until we get to processes. So we're not really going to do much with permissions till we get there. So we're good there, but what we're going to do now is we're going to go ahead and create directories and play around with that a little bit. So we're going to kind of done with stat, which is good, but we're going to go ahead and we need a path. So I'm going to go with 4. I think one of these was a directory. Yes, there we go. Boom. Right? I want that, but you're going to see what I'm going to do with it in a minute. Okay. Very first thing I'm going to do is I'm going to get current working directory. Okay. Now, see, okay, current working directory. I'm going to go get it. Okay. I'm going to pass the directory and it's going to bring it into the working directory. Watch. So I can't read the thing above. It's file name, right? Right. Boom. All right, I'm screwing up. Get work current working directory. Hold on. Current working directory. Does it take a size? No, it doesn't. Since when does current working directory take a size? Oh, size of the buffer. Yeah, it does. Um, we'll go with 255. Yes. Now, what I'm going to do is, for shits and giggles, we want to make sure we're getting something useful. I'm going to go ahead and print the file name. That's it. Nothing special here. And I get a segmentation fault. I'm using get current working directory inappropriately. I don't remember if I'm doing it weird. And I think I am. Let me just look at an example real quick. I don't need an example. I just want to look at it. It's a pretty simple thing. It's been used a million times. Yeah, I'm aware. I want to look at a quick example. I don't care about change directory. Yeah, we just check to see if it's null. Okay. So I don't do anything with the get working directory, right? So I go this. Oh, I know what I'm doing wrong. All right. Sorry. Um, So I'm going to go ahead and use 255. I'm going to put it in file name and it should print it out. What are you doing? All right, hold on. Sorry, give me a second. I have too much going on at once, I think. Do 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 do. There's no standard lib, and there is no standard lib. Yeah, of course. Yay! There we go. Ta-da! Now, I'm gonna show you something that's gonna seem weird. Okay, so I'm gonna go. It was four, right? Current working directory. It ran the same program, but I'm running it in the code directory. Now I'm gonna run it in my home directory. Yes, current work directory is wherever you happen to be. So be aware that that actually can move. And one of the things we use current working directory for is to move to a specific directory in order to do something. So let's create another example of this where I'll do exactly that. So we go here, and I want to use, and I'm going to call it a temp directory. And I don't remember what I used earlier. Was it this guy? Yeah, it was this guy, right? We'll just copy and paste it. Nope. This is five. I thought I was working in five. No, I haven't named it yet. There we go. Thank, right? So the temp directory is here. Get current working directory. Bang, I'm going to print it out. I'm going to, already forgot, by the way. I already forgot what I'm doing here. Forgot because I'm brain farting. I want to change directory. Okay. So I'm going to change directory to the temp directory. Nope. Temp dir. I'm going to do the same thing and I'm going to print it out again because why not? Okay. And all this is going to do is it's going to change the working directory and then it's going to go to the new directory and then print out that new directory. Not very exciting if you think about it in terms of real, like, ooh, what does it do? That's it, right? It's not super exciting, but it is relatively important. We do this all the time when we need scratch space or we need something that we need to save things to. As you can see, home student code, bang. All right, let's go to the terminal. Okay, okay. We have the same thing, and I'm not sure why it's highlighting it so weird, but let's go with five. You can see the working directory is initially home student, then it becomes that, and then of course I change it back. So I might want to change it back, and so I change it back if I choose to do that. That is a pretty normal set of operations that we do, and that gives you scratch space. So if I want to open a file or change a file or do something, that's what I do. It's pretty simple. We can go ahead and make a directory. That's what was about to do next. I'm going to go copy all this because we're going to do it in such a way that wherever the working directory is, we don't care. We're going to go into the main directory, then we're going to make directory. And what directory we're going to make? We're going to make a directory named, I'm sorry, brain farting. Keep opening this for some reason. I don't want that. I want this. Make directory constant car path, and it gives it a mode. So what I'm going to do is give it a file name like dir, I don't know, can't think of a thing, and a mode T, right? I actually saved that as mode T on purpose. It's going to obviously fail to compile. But what I want to do is open 107, and I don't remember which file it is. Is it long word? Where I go to create a file? I don't remember. Might have been P3C. No idea. Nope. So, um, cancel. Let's go ahead and do it the old school way. We'll go ahead and open the folder. We'll go 107, click open, save them all. This is, ooh, I don't want to save it there. I'm trying to save it here, and this is going to be 6. Let's see. Okay, it's going to open up the other one. I just don't remember the mode T, by the way. Just give me a second. P34, 4. Did a create, by the way. That's what the one I was doing. I was trying to do a create, and it didn't let me. Go ahead to use that long mode thing, which there it is. Yes. Open folder. I'm gonna go back to 109. Right? And we're gonna change this to mode. Do. And then we should just see what happens at this point, right? Do. So it should not open it should not open anything here, right? There should be no directory named dir here. But if I go into code and I go into 109, because the current working directory was in fact 109, there should be a directory named dir. And it should have the permissions listed before, right? Yay. Okay. Ooh, permission denied. Why is permission denied? Oh, because I don't have read, write, execute. I don't have execute permissions. Of course I don't. Read user. It's not X. Is it? Yeah, it is actually X. I just need permissions to read it. Yes. And of course I'd have to delete the, right. Yay, it's gone. All right, so I'm going to run it again. It does not matter where I run it. It's going to actually create a directory. And now, because I have the correct permissions, if I go into dir, I can cd. You need actual permissions. Now, let's suppose I want to change directory into it, right? So I go to change directory into dir. Yes? So what I want to do now is get the current working directory and print the file name. Okay. This is going to be a little bad. Oh, and I need to save this as 7. So we have a new one, right? This is not going to work the way we want. Okay. Oh, wait, it did. Okay. Because I went to from the change working directory, it actually worked. Yay. Okay. Now, suppose if I make another directory here? Would it allow me to do that multiple times? Yes. I'm going to do this here, and I'm just going to paste it, right? They're like, no way this works. Why not? It just keeps moving in the directory. This is because this is a relative path. You can use a relative path, but there is no relative path. If, for instance, I go dir2, this should fail, right? Because there is no dir2, right? Wait, I did save that, right? This is 7. Yes? Note, it did not change that directory. It just failed. That is the error response that returns with the change directory. It changed directory and then it failed. What if I want to remove the directory? Okay, we can do that. I don't really care that much. But what I want to do instead is I want to make a file inside that directory, inside dir. Okay. And you go, wait, what? I'm going to show you. So I'm going to go into the terminal. And one way to remove anything positively, no matter what you want to do with it, RMRF, and it's gone. Okay. So I'm going to do this. I'm going to go into the directory and I'm going to touch file one, touch file two. Okay. Now there's two files in that directory. Okay, great. So now I'm going to change working directory into, actually, you know what? Um, works if we change to dir. Okay, leave that there. Okay, so we're going to grab all this. We're going to go back here. We're going to go file, new text file, and then we're going to save. And then I'm going to get rid of this. We don't care about that. Okay, we make directory. We're going to make the we make the directory, print out the directory, and now I'm going to remove, right? Just going to remove file one. Oops. I got to go remove file one. Note, I'm not really caring about the return type. The return type is going to be 0 if everything works. The return type is going to be non-zero. If it doesn't work, it's going to be 0. So we can check that if we choose to do that. I'm not. But I'm just going to show you ls right. Do it again, and it's gone. It is deleting the file. Remember, if I had two names for the same thing, if I had two links, but if I remove and use remove, um, it works. Okay. Now I'm going to leave it there, and you're going to note, watch, it's going to return a nothing. It's not going to do anything, but it runs. And you go, what do you mean? Because it returns a 0 or whatever, right? We're just ignoring the return type. One thing I want to add too is I want to add a move. And this is the last thing I'll do today. I'm going to move file 2 to file 3. Note, if I move it to file 1, it'll disappear on the next round. Oops. Did I name it wrong? I probably did. It's rename, not move. I'm sorry. Yes. Oops. Not happy. There we go. And then I go back to my terminal, and now I no longer have a file 2. I have a file 3. Note these do have return types, make directory, change directory, and so forth, and they fail based on their return type. So it's not going to complain, it's not going to throw an exception, and those type of things. A couple other things we're playing around with, we haven't really played around with much. We're going to play around with more next class. Is I'm going to show you a couple of things about full pass versus uh, um, trying to think of the word. Full pass versus uh, relative pass. That's going to matter when we go to open or close files and so forth. So it's really important that we know what we're doing. And then we have a full path when we need a full path, and then we do the things that we need to do. But I will do that next class. Thank you all and have a great day. That concludes today's presentation.